Hello dear students, this is Asif Javed, once again welcoming you to the lecture series on Jammu and Kashmir State Eligibility Test. This is lecture number 3. In lecture number 1 and 2, I have discussed certain problems from this paper 2 of Jkset 2016. Today I will be taking some more questions. So let me take the first question, this one. If you look at this function, this is greatest integer function. So greatest integer function, what do you know about greatest integer function? This is one of the functions out of a class of functions that we call as step function. Now this is a step function with a step length of 1. The most important thing about this greatest integer function is that it is a discontinuous function and it has discontinuity at integers. So if I take any two a and b real numbers, then obviously this may not be continuous on a closed interval having a and b as endpoints, because if that will include an integer, then that function is going to be discontinuous at that integer. So the first option seems to be wrong. Of course it is wrong because this is a discontinuous function. So if I take, suppose 1 and 3, I take closed interval 1 comma 3, obviously this function is not continuous in this interval, because there is a point 2 at which this function is discontinuous. So the first option is wrong. Now if some function is not continuous, obviously it cannot be uniformly continuous, because continuity is a necessary condition for a function to be uniformly continuous. If a function is uniformly continuous, it has to be continuous. Or in other words, we can say if a function is not continuous, it cannot be uniformly continuous. So this is also not correct. Riemann integrable. Now what about a function? What are the classes of functions which are Riemann integrable on any interval? There are some results like every continuous function is Riemann integrable. Not only continuous functions are Riemann integrable, but discontinuous functions are also Riemann integrable. Like a function having finite number of discontinuities, this is again Riemann integrable. Not only that, but if you have the set of discontinuities whose limit points are finite, then again that function is going to be Riemann integrable. If we collect the set of discontinuity of this function, this consists of integers. And now if you take the limit points of integers, then this is going to be an empty set. So we can say that the set of continuities, that set of discontinuity of the this greatest integer functions, which is a set of integers, if we take the limit points, it's going to be an empty set. And we have been given relaxation up to finite number of limit points if there are in the set of discontinuities. The set of discontinuity, if the limit points of that set are finite, then still the function is going to be Riemann integrable. So obviously, since it is empty set in this case, so it is going to be Riemann integrable. So the C option is correct. So this is how we approach this function, and obviously if C is the correct option, then D cannot be the option of this. Now this was a very important question. Fine, let's move ahead. Now look at this question. You have been given a spanning set. Now what is a spanning set of a vector space? A spanning set of the vector space is that set which generates the whole vector space. Now there are two results in vector spaces which are very important. One is, if you have a linearly independent set, then you can extend linearly independent set to be basis of V. आप अगर आपके पास कोई लीनियरली इंडिपेंडेंट सेट दिया है, सपोज उसमें आपके पास n एलिमेंट्स हैं, तो उसको आप n एलिमेंट से बढ़ा सकते हैं यहाँ तक कि आप उसे बेसिस बनाएं वेक्टर स्पेस का। इसका मतलब ये हो गया कि जो लीनियरली इंडिपेंडेंट सेट होता है उसमें बेसिस से कुछ एलिमेंट्स काम हो सकते हैं। इसी तरह से जो स्पैनिंग सेट होता है, यानी जो जनरेटिंग सेट होता है किसी भी वेक्टर स्पेस का, उसमें ऐसा हो सकता है उसमें कुछ मजीद एलिमेंट्स भी हो सकते हैं, एक्स्ट्रा एलिमेंट्स भी हो सकते हैं। दैट मीन्स यू कैन रिड्यूस दैट टू बी बेसिस ऑफ वेक्टर स्पेस। तो जैसे इस केस में ये आपका स्पैनिंग सेट है, अगर इसमें n एलिमेंट्स हैं तो इसके बेसिस में n से कम एलिमेंट्स भी हो सकते हैं। और आपको पता है जितने एलिमेंट्स बेसिस में होते हैं वही आपका डायमेंशन बताता है वेक्टर स्पेस का। तो इस केस में जो आपका डायमेंशन होगा वेक्टर स्पेस का, वो या तो n हो सकता है, वो या तो n हो सकता है या n से कम होगा, क्योंकि इस केस में या तो हम उसे डायमेंशन यानी बेसिस के बराबर अगर होगा तो n होगा, या फिर उसे रिड्यूस करना पड़ेगा हमें बेसिस बनाने के लिए। दैट मीन्स इन दैट केस इट विल हैव डायमेंशन लेस देन n. So this is all I have in this short video. Thank you so much.